Welcome back friends to Stuffing Minds, and this is our new video, and in this video we are going to talk about time travel. It is a topic which is very common and it might be there in all of your minds. So today we are going to talk about this topic only, and I am sure that this is very interesting topic, and it will it will increase your knowledge about time travel. So let's begin our video. So, as we all know, everyone can travel in time. You do it whether you want to do or not, at a steady rate of 1 second per second. You may think there's no similarity to traveling in one of the three spatial dimensions at, say, 1 foot per second. But according to Einstein's theory of relativity, we live in a we live in a four-dimensional continual space-time in which space and time are interchangeable. Einstein found that the faster you move through space, the slower you move through time. You age more slowly, in other words. One of the key ideas in relativity is that nothing can travel faster than the speed of light, about 186,000 miles per second. It is around 3 lakh kilometers per second, or 1 light year per year. Light year, I want to tell you, light year is the unit of measurement of distance in space, but you can get very close to it if a spaceship were to fly at 99% of the speed of light. You had see it travel a light year of distance in just over a year of time. Then that's obvious enough. But now comes the world part. For astronauts on board that spaceship, the journey take a mere 7 weeks. It's a consequence of relativity called time dilation, and in effect it means the astronauts have jumped about 10 months into the future. Traveling at high speed isn't that only way to produce time dilation. Einstein showed that gravitational fields produce a similar effect. Even the relativity weak field here on the surface of Earth, we don't notice it, but because we spend all our lives here. But more than 12,400 miles, 20,000 kilometers higher up, gravity is measurably weaker, and time passes more quickly by about 45 microseconds per year. That's more significant than you might think, because it's the altitude at which GPS satellites orbit Earth, and their clocks need to be precisely synchronized with ground based ones for the system to work properly. The satellites have to compensate for time dilation effects due both to their higher altitude and their faster speed. So whenever you use the GPS feature on your smartphone or your car's stat nav, there's a tiny element of time travel involved. You and the satellites are traveling into the future at very slightly different rates. But for more dramatic effects, we need to look at much stronger gravitational fields, such as those around black holes, which can distort space-time so much that it folds back on itself. The result is a so-called wormhole, a concept that's familiar from sci-fi movies, but actually originates in Einstein's theory of relativity. In effect, a wormhole is a shortcut from one point in space-time to another. You enter one black hole and emerge from another one somewhere else. Unfortunately, it's not as practical a means of transport as Hollywood makes it look. That's because the black hole's gravity would tear you to pieces as you approached it. But it really is possible in theory, and because we are talking about space-time, not just space, the wormhole's exit could be at an earlier time than its entrance. That means you would end up in the past rather than in the future. This raises problems of different kind, not in science or engineering but in basic logic. If time travel is allowed by the laws of physics, then it's possible to envision a whole range of paradoxical scenarios, Some of these appear so illogical that it's difficult to imagine that they could ever occur. But if they can't, what's stopping them? This is the question. Then, thoughts like these prompted Stephen Hawking. I want to tell you that Stephen Hawking was a very famous physicist, American physicist, and he died recently, who was always skeptical about the idea of time travel into the past to come up with his chronology protection conjecture. The notion that some as yet unknown law of physics prevents closed timeline curves from happening, but that conjecture it's only as an educated guess, and until it is supported by hard evidence, we can come to only one conclusion: time travel is possible. This is very interesting part of the video. A party for time travelers. Hawking was skeptical about the feasibility of time travel into the past, not because he had disproved it, but because he was bothered by the logical paradoxes it created. In his chronology protection conjecture, he surmised that physicists would eventually discover a flaw in the theory of closed time-like curves that made them impossible. In 2009, he came up with an amusing way to test his conjecture. Hawking held a camping party show shown in his Discovery Channel program, but he only advertised it after it had happened. His reasoning was that if time machines eventually become practical, someone in the future might read about the party and travel back to attend it. But no one did. Hawking sat through the whole evening on his own. This doesn't prove time travel is impossible, but it does suggest that it never becomes a commonplace occurrence here on Earth. So that's all about the video. If you like the video, then make sure to like, subscribe, and share this video. Thank you.